For our last video in our series on relativity for day 2, we are going to look at velocity addition. So let's say we have two spaceships. One's going this way at about 3/4 of the speed of light. We've got another ship going this way, also at 3/4 of the speed of light. Now if we add up these velocities the way Newton would have, someone on this spaceship observing the other would say it's moving away at 1.5 times the speed of light, or 3/2 times the speed of light. But there's an issue with that. If our position is given by this formula, then one of the things you'll notice, if you were to graph this in terms of v, is that it goes asymptotically at v equals c, which means we can never hit the speed of light. Same thing happens with time. Nothing in the universe can travel faster than the speed of light. So what's happening here? If nothing can travel faster than the speed of light, how does this work? Is there a problem with the equations? Is there a problem with the way we add velocities? Well, let's make a slight change. We still have our spaceships going back to back, and from someone sitting smack dab between them, they're saying that they're each going at 0.75 c, or 3/4 of the speed of light. We still have our observer on this spaceship who's watching the other one and is going to measure that speed. Now let's assume the spaceship on the right turns on its headlights. Well, now we have light moving at the speed of light. This observer will say there's one speed for the spaceship, and the light is moving at speed c because the speed of light is always the speed c. So therefore, this light is faster than the spaceship. It's moving further to the right. So therefore, the speed of this spaceship has to be less than the speed of light. So the issue is the way we add our velocities. We cannot add these the way we did with Newton and get 1.5 times the speed of light. The number has to be less than that. So this is out. So what are we going to do? How are we going to enforce this light speed limit that we can see? Nothing can accelerate past the speed of light, because if you're sitting here watching, you'll see them getting faster and faster, but a photon moving past it is always going to be moving the speed of light and will always be faster than this guy. Well, we can go back and remember our very definition of speed is the change in position divided by the change in time. But the position and time have to be measured by the same observer. So if we have an observer who's measuring them in this reference frame, then our change in position is going to be delta x minus v delta t all over the square root of 1 minus v over c squared. And our change in time is going to be delta t minus delta x v over c squared, and that's also over the square root of 1 minus v over c squared. Now these cancel out. So that we're not going to get. What we do get is delta x minus v delta t over delta t minus delta x v over c squared. Or if we say that delta x over delta t, v is the speed of that reference frame, we'll use the letter u by convention for the speed of the object as we're measuring it. If we divide top and bottom by delta t, this becomes u minus v over 1 minus uv over c squared. So now v is the speed of our reference frame. So our pilot, who's moving to the left at 3/4 light speed, is going to be measuring something that we see as 0.5 c. That pilot is moving at negative 0.75 c. And this is going to be over 1 minus 0.75 c times a negative 0.75 c all over c squared. So our modified velocity here is 3/2 c over 1 plus, and this is 3 over 4 times 3 over 4, so that's 9 over 16, and the c's cancel. Combining our like terms, we get 3/2 c. We have a common denominator down here, 25 over 16. So the 16 comes up, multiplies by the 3, we get a 48. The 2 comes down, multiplies by the 25, we get a 50. So we're moving at not 150% of the speed of light, but 96% of the speed of light. It's 24 over 25 c. So if you were to actually take this expression and you plot it as u goes from 0 to c, you can even go from minus c to c if you want, you will see that u primed also stays within that minus c to c range. So no matter what our speeds are, everything travels less than the speed of light. And that is one of the biggest implications of the universe and of this special theory of relativity. The speed of light is not just the same for speed, it's a speed limit for existence. That is an implication that also pushed people to oppose the theory of relativity. Keep in mind, though, the oppositions that we were getting to the theory of relativity were not based in experiments that contradicted the theory. They were based in people going, I don't like that. I don't want it to be true. The universe is under no obligation to give us rules that we want. It has a set of rules that we can discover and we can learn more about, but we cannot control. Tomorrow, we will take a look at electricity and magnetism and how they work in relativity.